Hello everyone. So here we have the study of tuning fork. We'll take this into account and we'll work on SIMULIA works. The tuning fork of 440 Hz resonant frequency. I'll utilize the structural designer to deal with this. The simple static study and frequency and thermal study will be available over there. So I'll deal with the frequency. So in this, I'll simply apply the material and measure it. I'm gonna just fix the bottom end of it to deal with that. So let's define the material. For this case study, I'm gonna consider the steel materials. So inside the steel, I'll select chrome stainless steel for this, for our reference. Yeah, so once the material specification is done, I can mesh it. So in the mesh, you can choose automatic meshing, simply generate mesh, but I want to refine it. What I'll do is I'll make it from 1.84 to 0.5 mm. So you can see the mesh now, it is coarsen compared to the previous mesh. Yeah, so the mesh is fine, it's absolutely fine for me. So here I'm not gonna deal with any forces and all, so I'll simply just utilize the constraint, apply the fixture, that is clamp, and 3DEXPERIENCE SIMULIA works. So I'll simply select these all the bases. I'll fix it, and then finally I'll simply run the study to get the results with respect to frequency analysis. So we are using structural designer. We'll have the availability of only 4 cores here. So if you are dealing with the structural performance engineer and durability performance engineer and mechanics engineer, we'll be having the 8 core as a reference, so that we can run the simulation with less period of time. Yeah, so we have the results here. It's in the form of deformation, and the first frame in natural frequency is 228. There are normally 10 natural frequencies we have calculated here, but the fourth natural frequency is 443, which is near to our practical natural frequency of 440 Hz. So how we can validate this? So what we can do here is, by utilizing the animations, we need to check the practical deformation, the practical mode, how it gonna deform. So I'll just switch to different studies here. You can see this is the first natural frequency, this is the second one, this will not be the practical deformation, and even this third also, and the fourth one. So comparatively, this is the mode which we're gonna get in the practical scenario. So from the conclusion we can conclude here is the fourth natural frequency is matching our resonant frequency. Yeah, so now instead of considering the fixture, I'm gonna just take the entire model and then create a one more study, that is frequency. I'll simply mesh and run this without applying any constraints. So what gonna happen, we'll just check here. So we already know if we keep any component inside the space, and if you want to check the frequency of it, the first 6 natural frequencies will be 0 for it. So you're gonna constrain all the 6 degrees of freedom, and then it will jump to the the practical modes of shapes. So as you could see here, the first natural frequency, the first deformation and the displacement, the mode of deformation is 0, right? And even we could see the list here. The second one is also 0, and same thing for 3, 4 and 5, and even 6. So the software is trying to constrain the model in all the degrees of freedom. And finally, the 7th mode is 444 Hz. So the thing is, the mesh is comparatively coarse, so it is giving. So from this, what we can conclude is, by doing the frequency analysis, we could able to achieve the natural frequency of 440 Hz in the both scenario by just fixing the one end and even by keeping it free. Yep, that's all about this session. Stay tuned.